of the problems from this competition because there just honestly isn't enough time for that. We're just going to look at the ones that one of the other people working here have compiled and found to be the most interesting for us to take a look at and the most worthwhile.
Yeah, I also heard that they're pretty dang difficult.
Oh, we did not compile them. No, that would defeat the purpose of a live solve because then you would have
Uh-huh.
seen them.
This is all live. Like, this is our first time seeing the problems.
Yeah. Okay. What do I want to do here? Maybe let's combine those. So that's what? xy plus x plus y plus 1 all over xy. We know x plus y is 10, so that is 1 plus 10 plus 1 over xy. And then if we want to minimize xy, so no, we want to, do we want to maximize or minimize xy? I think we want to maximize xy.
Yeah, I agree with that.
Yeah. So that would mean that we want to have x equal to y, both equal to 10 halves. So 1 plus 11 over 5 squared, which is colloquially known as 36 over 25, thus making our final answer 36 plus 25. Oh, that's right over the light, isn't it? Kind of important that you guys can see the final answer. There we go. And that is simply 61. What do you think, Aiden?
Yeah, I think everything seems right. And Crackling Cherry also said that they put 36 over 25 in the contest, which is unfortunately not the right answer, but it's what we got.
Yeah, it's
After we
important
sum it, though.
to double check what the question asks for. Otherwise, you make sillies.
Yeah.
Okay.
Awesome.
Yes.
All right, so I will do the next question. This is combinatorics number 7. So in this question, Orion, a student at FizBad, throws 2 balls into containers labeled 1, 2, all the way to n. If the probability that the ball lands in the container K is 2 to the power of negative K, find the probability that the balls land in the same container can be represented as P, where the factor of P and Q is 1. Find P plus Q. So the first thing I notice is that this problem makes sense because in container 1, the probability it lands there is 1 over 2. 2 to the power of negative 1. Container 2, it's 1/4, it's 1/8, and so on. And since the probability is sum to 1, we have to check that 1 over 2 plus 1 over 4, and so on, this is equal to 1. So this problem does make sense, which is good. Now, onto what the problem is actually asking. The probability that the balls land in the same container. So we throw 2 balls, and we want the probability they land in the same container. Okay, let's do this step by step. Let's first calculate the probability that they both land in container 1. That would be 1/2 times 1/2. And then as for container 2, this time it'll be 1/4 times 1/4. For container 3, it's almost the same thing, just higher powers of 2, 1/8 times 1/8. And then now you can see the pattern. This is 1 over 2 squared, and this is 1 over 2 to the 4th. This is 1 over 2 to the 6th, and we have a geometric sequence again. So we could do this by using the formula, or you could set it as x and then do some manipulations. I'll just go and directly use our formula. 1 over 4, first term, divided by 1 minus the common ratio, which is also 1 over 4, which gives the answer of 1 over 3. But that's not the answer. We don't want to make a bad mistake. The answer would be p plus q, which gives the answer of 4. Does that look about right, Megan?
I think so. And yeah, good job remembering about the P plus Q thing, because that's tricky.
Yeah, very tricky. And yep, the answer is 4. Very nice.
Okay, well, in that case, I think we're on to geometry. This doesn't look like geometry, but okay. Write the volume of the region enclosed by the graphs of x to the 2022 plus y to the 2022 plus z to the 2022 equals 1. And x minus 1/2 to the 2022 plus y to the 2022 plus z to the 2022 equals 2.
Oh my God. That's very big.
Okay. So, honestly, I'd rather a traditional geometry problem, and I don't like geometry. So, x to the first one, equation 1, is going to have a it's going to be basically a cube of from -1 a cube of plus or minus 1 from origin. Not exactly, but since it's so big. Is there an easy 2D version? Why is it a cube? Okay. So the reason why I say that it is a cube is because, wait, no, shoot. I forgot how large powers of numbers less than 1 work. Okay. Well, okay. I still know that there are points plus or minus 1, 0, 0, plus or minus, nope, 0 is always 0. And then the other one is just going to be 0, 0, plus or minus 1. Yes. And the, yes, okay. And the other one is, well, okay, so each of the constituent parts, the x term, y term, and z term, will equal 1 when they are 3/2 or -1/2 plus or minus 1 and 0 or 2. So we want to find the area of the region enclosed. Oh, and we are rounding to the nearest integer. So that will definitely help us. Is anyone good at drawing rectangular prisms? I have a very funny story about that, but we will work at that afterwards.
Wait, actually, I have a slight objection. I'm not sure if I'm correct,
I will
but
take any objection.
I'm thinking the figure might be more of like an octahedron, possibly.
Right.
Because, okay, this is random scratch work, but if we look at it more carefully, so suppose that for this first equation, if z is 0, then we get a two-dimensional plane. And then the equation would be x to the power of 2022 plus y to the power of 2022, that's on my face, is equal to 1. And I was trying to imagine what the two-dimensional graph of y to the 2022 equals 1 minus x to the 2022 looks like. And I'm guessing it's something like y is equal to the absolute value of x.
See, we have a good point in chat from Crackling Cherry, which is actually just that they'll both be pretty dang close to 0. Like, always.
That prompts a thought. I think because the answer says round your answer to the nearest integer.
Yeah.
Since the numbers and the powers are so big, I'm sure we could do some sort of like hardcore rounding,
What if I'm
estimating.
just like 0? Done.
That I'm not sure because there's definitely still some area enclosed in this octahedron.
True, but if it's less than 1/2, then our answer is 0.
Less than 1/2.
Good, because rounding.
That seems like an interesting point. Let me think about this real quick.
Yeah, because I think it's gonna look like not even an octahedron. On further investigation, I think the 3D plane looks kind of like this right here, like just like really pointy and all that, right? And since it's so like just given like the area of overlap, like the area of overlap is going to look like this star, but to then moved up one, it's moved up one vertically, to the right by 1/2, on the x-axis. I don't know if it's right or left, but it's moved like that, and then like slightly scaled in volume to what? The cube root of 3 times as large? Like, that's not going to have a lot of overlap, is it?
Yeah, that makes sense. Let's see. Yeah, that brings up a good point because if we put 0.5 for x and 0.5 for y, then z would be very close to 1. 0.5, 0.5, z would be extremely close to 1. No, it would be 0. Oh, I was thinking for this first equation, if we plugged it in like this, because x to the 2022 would basically be 0, y to the 2022 would basically be 0, and then that forces z to be somewhat close to 1 to get the equation.
Yeah, okay. So I think the final answer is just 0 then? I'm
Have we
curious what
considered have we
yeah.
considered the volume of the region enclosed by these two yet?
I mean, see, it's going to be really small. Like, if you look at just the first one, right? Like, we take the cross section. Like, this is like, I'm pretty sure that's like over exaggerated. It's probably going to look like that is like the cross section. You can see, like,
Okay, I see where you're getting at. So if we have a plane where z is equal to about 0, then x to the 2022 plus y to the 2022 is equal to 1. That would be, so if x is something like 0.5, then y would basically be 1, and vice versa as well. And then we got negatives as well, so negative 0.5, and then
yeah.
that would be about this, and then -1, that'd be about this. And of course, since it doesn't really matter the signs right now, it's symmetrical in all 4 quadrants. That's something we know for sure.
Yeah.
And then as it gets closer to 0, then we actually stay really close to 1. Okay, Megan, do you think the graph looks something like this actually? The cross section?
Huh.
Because I was thinking like if we take an x, this is a little hard to see. Let me move this. If we take an x a little bit below 1, like 0.9, it would still be super small, and y
Yeah.
would have to make up for it by being almost close to 1. So there might just be this small area right here that curves in a little bit, and then the rest has to be almost in line with 1.
Makes sense, yeah. Huh.
Okay, so this is when z is equal to 0. We have to figure out what happens when z is not equal to 0. Okay, so if we look at the original equation, for any z less than 1, it may as well be 0. Yeah, I agree with that. So essentially, this graph, the cross section for z is equal to 0, might be about a square, almost a square. And then for z is equal to like 0.1, it's also about a square. And then all the way until z is equal to 0.9, it's also about a square. And then there's that tiny volume when z is equal to 1, where it's probably not just a square. So if we come back here and look at this, that amounts to almost like a cube.
Yeah.
And then this other equation is just a scaled by 2 cube, which has 8 times more volume, and then moved somewhere. This is moving right on x by 1/2 and moving down on z by 1. Oh yeah, and there's one claim that we know for sure is that none of x, y, or z for the first equation could be greater than 1, because all of these are perfect squares, so they must be positive. So let's see. What if we just say that they're both cubes? We have, this is a 2 by 2 by 2 cube, the first equation. And then the second equation, this is the center. You moved it via x by half. That'd be something this. And then y via 2. This would actually be the halfway point. And then that'd be there. So then connect these. This is the center of the 4 by 4 by 4 cube. And that's going to engulf this cube. These side lengths are 2 and 2. And right here, the height is it 1? it's not 4 by 4 by 4 because 2 to the 1 over 22 power is basically 1.
True. Yeah, so you can have two ones. Like you can have the y term equal 1 and the x term equal 1, but you could have one of the terms be slightly greater than 1 and it would be 2.
Okay, the key is getting the shape of these. So x to the 2022 plus y to the 2022 plus z to the 2022 equals 1. We have to decide what shape that is.
I think the equals 1 is a cube of side length 2.
Yeah, I think it's side length 2 because we could do it this way. We know x squared plus y squared plus z squared equals 1 is a sphere. And then if we have x cubed plus y cubed plus z cubed equals 1, this would be, so if we plug in half, that, and then another half, and then we get something like the cube root of 3 over 4. Plot that on the graph, that would look like we have the ones, and then we'd have half, half, and then somewhere here. This would be a little bit impractical though, because the powers are odd this time. I do think it should look somewhat like a cube though.
Yeah. Well, okay. So if we center it at 2, 0, negative 1, we know it's equal to 2. So we know that the points 1, 1, 0, or in any arrangement and in any positive or negative, all work. But I think that's just a cube of slightly less rounded corners than our original one. What do you think, Aiden?
Yeah, I think it's something like a cube because I have a new reason to believe so. Because if we look at x plus y plus 1, let me write that in a different area. And then reflect it through all of the quadrants in this 3D coordinate system. That's like an octahedron. The sides are all straight because it's a plane itself. And then x squared plus y squared plus z squared equals 1 is a sphere. So it's as if we're pulling the lengths outwards. Eventually, when it gets to 2022, it's so outwards, it'll look like a cube. Now the trouble is, how do we overlay the cube?
I think I have the answer to that. So on the x-axis, there's an overlay of 3 halves. On the y-axis, an overlay of 2. And on the z-axis, an overlay of 1, give or take-ish. But then we multiply those 3 together and we get 3 as our final answer, which is an integer, which is good.
Oh wow, that's really smart. Let me think about this. The z would be 1, yeah, because we have negative 1/2 here, that shift. So that leaves 2 minus 1/2, which is 3 over 2. And then y doesn't change, so it's still 2. And then z, that's 2 minus 1, which is 1. And the reason it says round to the nearest integer is because we're assuming it's a cube, but there's only that super tiny difference. So I agree with your answer, Megan.
Okay. Took us a while, goodness. Okay.
All right, let's see if it's actually correct. Okay, awesome. That's really good.
Finally.
All
I
right,
would give you a high five, but we're across the nation.
that's fine. High five. All right, so I'll read the next geometry problem. Hopefully this isn't as bad. Yeah, I think that was cool as well.
Oh no,
Anyways,
this looks scary.
point A, B, C, D are in the Cartesian plane as such that A is equal to this ridiculous coordinates, B is equal to a bunch of this, C is equal to this, and D is equal to this. Given that point P is in the same plane, the minimum possible value of PA plus PB plus PC plus PD is closest to which integer? So the first thing I'm going to do is subtract 2018 from all of these coordinates, because that doesn't change distance. So point P, we just need to remember, point P, we minus 2018 on both coordinates. Now, let's call it A prime. A prime becomes 30, 40. B prime becomes 0, 0, very convenient. C prime becomes something like 18, 28. And then D prime becomes, let's see, that is 42 and 21. If we want to draw these on the coordinate plane, that'd be something like, this is B prime, 30, 40, that's a right triangle actually. That'd be A prime. C prime would be 18, 28, so that would be somewhere in here. And then D prime is 42, 21, which would be something like this. And then we have a point P somewhere here in the middle, and we want to minimize the sum of the distances from each of the coordinates. How would we do that? Let's set P prime is equal to x comma y just for the convenience right now. I mean, one possible approach is to algebraically calculate the distances, sum them up, and then somehow find a way to minimize that.
Nah,
But
this is geometry. Let's do some geometry.
yeah, I don't see a really good route to doing that. All right, so what is another possible way to do that? Let's think about this. Do we notice anything special about the numbers? That's the first thing. Draw A, B, and CD. Yeah, I was just about to try that. And then we have A, B, and then CD.
Also, I just like to point out that Alice is very correct here.
Geometry is hard. If P is the intersection of the diagonals, that would give a value, but actually, what if P is the intersection of the diagonals?
I think it might be,
Because
yeah.
if P is anywhere else, then PC prime plus PD prime will always be greater than C prime D prime. And then PB prime plus PA prime will always be greater than A prime B prime. And since we know we can achieve A prime B prime plus C prime D prime, then that must be the smallest, right?
I think so.
Shortest distance between 2 points is a line. Exactly, not a triangle. That's triangle inequality right there. So my best bet is to just calculate A prime B prime, the distance, and then C prime D prime, the distance, sum them up, and hope that's the correct answer. But we have to do that first.
Math.
A prime B prime, let's see what that is. That would be the square root of, actually we know that by right triangles. This is why they chose right triangle numbers. Okay, A prime B prime is 50 from right triangles. And then C prime D prime is, this would be 24 squared plus 7 squared. And of course, this is an integer as well. So that's 25. And therefore, if I sum these together, I get a possible answer of 75. And as we said earlier, any p not at that point, if p anywhere else, by triangle inequality, it'll be greater than if p was the intersection of the diagonals. So I think the answer should be 25.
Yeah.
It should be 75, not 25.
Do we have to do anything with the fact that we changed A, B, C, and D? Is that going to affect this at all?
I don't think so, actually, because all we did was translate it. But yeah, that's a good point. We definitely should not forget about that. All right, we got to see if it's correct answer.
Yes, yes.
Okay, there we go. It is the correct answer. Very nice.
Okay, so what's the next question then? Define f of a, b, and c to be the least common multiple of the greatest common denominator of a and b, the least common multiple of a and c, and b and c, or b times c. Okay, and then we are trying to find the prime factorization of f of 2022, 9009, and 7. Okay. Honestly, I think the best way to do this is okay, first, factor the numbers. Yes, great idea, Jason. 2022 is equal to 2 times 3 times, it's not 667, it's not 670, something in between there. What is it? Is it 670? No, it's not. 674. Right, I remember how I was factoring this. 674 over 2 is 3, 3, 8, 7, yes. Arithmetic, not always my strongest suit, that's what a calculator is for. Okay, now, I think I can do 7. That one's just 7. And then 9009 is 3 squared times 7 times 11 times 13. Okay, so the first one, greatest common denominator of A and B, or greatest common divisor, sorry, is 3. Should we make it 2 squared? No, because 2022 isn't divisible by 4. The 674 number was for what 2022 over 3 was. But we were looking for the 1 over 6. That is a good point. Okay. GCD of A and B is 3. Unless 337 isn't prime, I'm pretty sure it is. Least common multiple of A and C is 2 times 3 times 7 times 337. And BC is 3 squared times 7 squared times 11 times 13. So, now we just have to find the least common multiple of those. So it's going to have a 2, a 3, a 7, a 337. It's already got a 3 for the first one. We need 3 squared, moving on to the third one. 7 squared, an 11, and a 13. And now all that's left to do is to figure out what this number is. So, how do we find out what this number is? Well, okay. We know that 2 times 3 times 337 is 2022, and we have a 3 left over. And we know that if we take that 3, multiply it by a 7, an 11, and a 13, we'll get 3 times 1001 times 7. So 21 times 2022 is 42462. Oh, wait, right, I forgot. We want to find the prime factorization, not the actual number. So we actually didn't need to do this part, even though it would be interesting to find the number.
That would be quite insane.
I don't think it would be that hard to find, but it'll definitely be easier to find what they ask us for, which is prime 1 exponent 1 summed.
For sure.
So 2 times 1 is 2. 3 times 2 is 6. 7 times 2 is 14. 337 times 1 is 337. 11 times 1 is 11. And 13 times 1 is 13. And now some good grouping. Okay. That's 20. Those two make 50. So that brings, no, not 50, 350. So that brings us to 370, 381, 383. Assuming that arithmetic looks right to you, Aiden?
That seems about right. Yeah.
Awesome.
Hopefully there wasn't anything we're both missing.
Yes. Yes.
All right. So
that was fun.
Yeah. Next question. We're on combinatorics 9. A bug starts at 0, 0 on the Cartesian plane. Each move, the bug can move to any lattice point exactly square root 5 units away, essentially like a knight in chess. By now, I have remembered that the square root of 5 is the hypotenuse of this right triangle.
That looks like a square, Aiden.
Okay, whatever. Essentially like a knight in chess. As long as it stays inside or on the square with vertices 0, 0, 0, 2, 2, 0, and 2, 2, let A be the probability that after 300 moves, the bug is back on 0, 0. Also let B be the probability that after 300 moves, the bug is on 2, 2. The value of A minus B can be written as 1 over n for a positive integer n. Find the remainder when n is divided by 100. So first off, I'm scared because that means n is pretty big. But let's not let that overtake us. Cartesian plane, the bug starts here at 0, 0. Each move, the bug can move to any lattice point exactly that units away, as long as it stays inside or on the square. So we do have some pretty tight constraints here. That's only 9 possible points. And then it jumps like a knight around these dots, and then we want the probability after 300 moves, it's back on 0, 0, and then also on 2, 2. The remainder when n is divided by 100 is equivalent to the number mod 100, which is equivalent to the last 2 digits. Yeah, exactly. That's absolutely correct. And then let's see. First of all, is it possible to land on the square 2, 2 after 300 moves?
Yes.
Let's see. So the shortest path to get to that would be 1, 2, 3, 4. And then it could just cycle through 2 points. Yeah, I think it's possible because 300 is an even number. And every time it changes spots, the parity of the sum of the coordinates changes. So for example, you start from 0, 0. The sum of the coordinates is 0, which is even. Next move, you might go to 1, 2. The sum of the coordinates is odd now. And then if you jump all the way to 2, 0, the sum of the coordinates is even now. So this even odd sum of coordinates cycles throughout. And then by move 300, we know that the sum of the coordinates is even, so 0, 0 and 2, 2 should be possible. Okay, now if we want to calculate the actual probability, first of all, I don't think the center dot is possible.
I don't
Because
think so either.
if you just jump around randomly, looks like you can start from this, you can go to here, perhaps you could jump here or here, and here sounds nice. You could go here, right here, and then jump here. But no matter how much you try, the center dot is impossible.
Yeah, because
So
there's nowhere to jump from that will land you there, or nowhere to jump to from there.
yeah, I don't know exactly why I crossed out the rest of the points. Let me just redraw that. But this time without the center point. That one's impossible. To find the probability, it gets back to this point by 300 moves. Why did I cross that out again? Okay, after 300 moves, we did make an observation earlier, is that after 300 moves, the sum of the coordinates must be even. So this time that eliminates this point, this point, this point, and this point. So in reality, we're left with 4 possible points. This, this, and this. However, in the process, on every even move, we land on one of these points. And I will make a bold statement. Is it possible to get from any of these points to any other point in exactly 2 moves? Is that
No,
possible?
you can't go diagonal in exactly 2 moves.
Yeah, so, but then the rest of them are good. So actually my statement is wrong, but okay, we got somewhere. That's good. Let's see. We could jump around randomly and try to figure out some small cases, but will that actually help? Oh, we could try this. Suppose we start at 0, 0, and the probability on move 2, we reach this. The probability that on move 2, we reach this one. So on move 2, there's a 1/2 chance that you go back. Because it doesn't matter which one you jump to first. Suppose you jump to this dot right here. Then your next options would be this dot or this dot. And those are your only 2 options, in fact. So returning to 0 would be 1/2. And then going to another one, let's label these actually, A, B, C, D. Returning to A would be 1/2. And then going to D would be 1/2. This sounds like a job for states. I'm not very good at states, but we could try. On any move, if you start at A, there's a 1/2 chance D is 1/4 because 1/4 for B. Oh, okay, I see what you mean, but yes, okay. You are really smart. Awesome. You get a star for that. Because if instead I go to this circle, there's a 1/2 chance for B and then a 1/2 chance for D. So that's 1/2 times 1/2 plus 1/2 times 1/2. So that is A has 1/2 and then B and D are the same, which are 1/4. Okay, I wish I could give you more stars for that, but that's a great observation. If you start at A, there's a 1/2 chance you go to A, 1/4 chance you go to B, 1/4 chance you go to D. If you start at B, this is symmetrical. That's a good thing. There's 1/2 chance you return to B, 1/4 chance you go to A, 1/4 chance you go to C, and then so on you go down here. It's the same for C and D. So now what we have to do is use all our information and find the probability that, what is jumping around again? A dot? A bug. Okay, a bug is jumping around. That the bug ends up at A or C. And then subtract those. The probability that it ends up at A starts as 1. So this is actually 150 jumps, because earlier we eliminated the random between jumps. Isn't the sum of all the probabilities concerning A, because they're exclusive? I'm not entirely sure what you mean by that. It's
I mean,
fine. You
all
get
of
a
this
star.
probabilities will sum to 1 because, yeah, you can't end it A and B and C and D. But you can
That's
only end
actually
at
genius.
A or C, can't you? The start or 2, right?
Actually, I think B and D are possible, actually, because if you
Oh,
just
right,
like
because you can just not
2,
move.
yeah. Wait, can you not move?
Well, you can effectively not move since there's
Oh,
a
yeah,
1/2 chance you just end up where you started, right?
I agree. Yep. So I think our biggest tool right now is that being at A, B, C, D is basically the same. So okay, I will do something very risky. I will set the probability that our 150th move ends at A, starting from A is P of A. And then we end up at D, the probability is P of D, P of B, and P of C. So basically I'm doing states. Then P of A is equal to,
Well, if you're at B or D, P of A is P of C. Like the
that
probability
is
that you end up at
completely
either
true.
of those is equal.
Yes, I think we'll need that in the future. Just like if you start at A, P of B and P of D are the same.
Yeah.
So why don't we just call both of them P of D? P of A, there is a 100% chance you go to P of D. But then the amount of steps it takes changes, and this is worthless.
Wait. I could be completely crazy here. But if we reach at any point B or D, then the probability that we end up at A or C is equal, right?
Yes.
So the only advantage that A has is if the only move is it goes somewhere and it returns back to A, and it does that 150 times.
Wait a moment, actually, I don't think you're crazy. I think that's a very good point, actually. For each of the 2 steps, each vertices share half its current probability with its adjacent points. Write down the probability of landing on a point for every 2 steps. Okay, so For each two steps, each vertices shares half of its current probability with its adjacent points. So technically, A would be equals to half B plus half D. First, it's 1, 0, 0, 0. Okay. Okay, this person, Jiayi will get 4 stars. That is genius. That is a way I've never thought about it before. So the probability of being at the square on move 1 for a ordered quadruple A, B, C, D, that's 1, 0, 0, 0. Because on move 0, this is actually move 0. There is a 100% chance that you are on A. And then on move 2, the things start to become random. Not on move 2. Yeah, on move 2. Okay. A splits its probabilities with B and D. As we noticed that earlier. 1/2, 1/4, 1/4, and then 0. And then on move 4, it happens again. This is a little more complicated, but 2, A would share its probability with B and D again. So A would become
It seems
1/4
very
for now.
simple in terms of the algorithm, but very annoying to compute by hand.
And then add 1/4. I will break this down slightly. So A, B, C, and then D. A, we would have, first we half it off, 1/2 times 1/2. And then B, that would be treat B and D sum to 1/2 always. Oh my God, yes, okay. B and D always sum to 1/2. So,
Wait,
and
Aiden.
A is always, yeah.
Let me see it writing again because.
Okay, I will
Okay.
talk.
Number 1. Oh, you put it A, B, D, C. I forgot.
Yeah, I changed that just now.
Sorry, I presumed alphabetical order and got very confused.
Yeah, it's fine, my bad. I did too, but then I changed it just 2 seconds ago. And then that'd be 1/2 times 1/4, because B and D are sharing. And then we would do this again. This becomes 1/2, and then you add 1/2 times 1/4 again. I see where this is going. So we do this 150 times. Let's see, what is this? This is 3/8, and this becomes 3/14 plus 1/8, not 3/14, 3/16. That'd be 5/16. So on move 0, we have a 100% chance you're at A. On move 2, it becomes 1/2. And then on move 3, it becomes 1/2 times 1/2 plus 1/2 times 1/4, if I'm not mistaken. It halves itself from giving away to B and D, and it receives 1/4 times 1/2. Or does it receive 1/2 times 1/2? B would give off 1/4 of it, so 1/16 of it. D would give off 1/4 of it, which is 1/16 of it, to A. So 1/8. This should be correct. And this expression is now equal to 3/8. And then we half it again, and then plus 1/8. That'd be 3/16 plus 1/8, which is equal to 5/16. We half it again, and then plus 1/8. 5/16 plus 1/8, 5/32 now, actually. That'd be 9/32. What I'm doing now is I'm trying to notice a pattern. Or if it's impossible to find the explicit value of A, we could find the difference and compare them.
Yeah, because that is only the goal. We're just supposed to find the value of a minus b and then do some stuff with that. So
There has to be some sort of pattern though, because we're halving and plussing 1/8 every time. 9/64 plus 1/8, 17/64. This is getting closer and closer to 1/4. Oh, okay.
and it's
So
always
Jai,
what 1 over some power. Yeah, it's like Jai said.
so 1/4 plus 1/2 to the power of n. That's our guess. Let's see. I think that's correct. I think this is perfect. And I will trust Jai and give him a star. Him or
Oh
her,
yeah, no,
actually.
that is the correct formula.
Yeah, awesome. And then now let's look at C. Because, okay, but B and D always sum to half. So C would be 1/2 minus this crazy expression, which is 1/4 minus 1/2 to the n. And we're seeking the difference.
So that's 2/2 to the n.
And then because it's 150 moves, this would be 1/2 to the 149. And just as a reminder, let's look back at the problem. Can be written as 1/n for positive integer n. Find the remainder when n is divided by 100. So this has become 2 to the power of 149 mod 100. And, this shouldn't be too bad, right? 1024 to the power of 14 times 2 to the power of 9, which is congruent to 24 to the power of 14 times 2 to the 9. We're looking for the last two digits, so we could do 76 to the 7 times 2 to the 9. And you know what? I'm going to simplify this with Euler real quick. Po-Shen function of 100 is 40, so this is congruent to 2 to the power of 29. And then now let's do that. 1024 squared times 512. So mod 100, that's 76 times 12. And we can do that. Let's do that real quick. 21157621. My answer is 12. Does that look right, Megan?
I think so. It is hard to say for certain because that was a lot of arithmetic and a lot of spots to go wrong.
Yeah, okay. I'm nervous. Let's see, what is the answer? Okay, apparently it's 24, so we're not that much off, but there's something that went wrong. Could it have been 1/2 to the power of 150? Yeah, that's what I'm thinking as well.
Probably the most likely, but why?
But why? Yeah, that's the key.
Do we start at 0 or 1? Because if we say that we start at 0, then it could change.
Okay, so this is move 0. 1 is move 0. Half is move 1. Oh, so in fact, okay, we messed up the. Okay, that is a lot of writing here. But we messed up the scale, what's it called? Shifting a little bit. For n equals 1 is actually n equals 2. Okay, so down here, it's actually, yeah, n equals 2. So on move 150, what we're trying to do is 1/2 to the power of 151 plus 1/2 to the power of 151. Yeah, we messed up the shifting a little bit. So this is 1/2 to the power of 150. And I'm not going to do that again. But yeah, the answer is 24. And y'all know why.
And it is now past 5 o'clock here.
7 o'clock here.
Yeah. It's past the o'clock wherever you are, unless that place is like India or whatever.
Yeah, it could also be past 12 a.m. I don't know.
True. But yes, that
But
does
yeah,
mean Oh yeah.
Did y'all enjoy the live solve today? Oh no, no one's typing. That
I'm
was
sure
hard.
they enjoyed
Okay,
it.
I
It was
agree.
hard, very hard.
Awesome. Okay, that was really fun for me, and I'm sure it's fun for Megan as
Oh,
well, right?
definitely.
Yeah. These problems were certainly challenging. I think this was a really awesome contest.
Yeah, definitely one of the hardest that
Yeah,
I've seen for live solves.
definitely.
This was for middle schoolers? I think so, yeah.
Apparently, yeah. We had like someone tell us that the problems were really, really difficult. So I was worried at first, but it's fine. We did it. We made it to
We
the
did
end.
it. They weren't wrong, but we did it.
Yeah, none of them was wrong. Not even 12 or 24, you know. Middle schoolers, yeah, this was a middle school contest.
Oh, I think it was the person who compiled the questions for us.
Yeah.
So maybe they're prophets, maybe they read the questions, I'm not really sure. But yes, I think that does mean that we are officially done with this live solve. Me and Aiden will stick around for a little bit longer if you guys have any questions. But yeah, hope you guys had fun. Thanks for
Thank
coming
you
by.
everyone for coming. Bye-bye. All right, let's see who has the most stars.
Oh, that's a good question.
Okay, actually, how do I check that?
You
Okay,
just need
well,
everyone to send a message.
yeah. Skylar has 4. Bye, Ivan. Thanks for coming. And oh, it looks like Ivan reset. I remember he had quite a lot. Bethany
Yeah,
Cherry has 5. Bye-bye. Thanks for coming. We enjoyed having y'all.
very much.